Welcome back to Level Up NJ. So today we are diving a very classic greedy problem named 134 gas station. So if you ever wonder like how to figure out the perfect starting point in a circular trip, so this one's for you. So in this video, I'm going to break down the equation and I'll show you the Java code in a few seconds. So first understand the problem statement and then we will move forward. So the problem is there are n gas stations along a circular route where the amount of gas at ith station is gas I. So you have a car with an unlimited gas tank and it cost I of gas to travel from the ith index to its next I plus one station. You begin the journey with an empty tank at n one of the gas stations. So given 20 years arrays, gas and cost, return the starting gas station if you can travel around the circuit once in the clockwise direction. Otherwise, return -1 if there exists a solution. If it is guaranteed and unique. So what are given? So we have two arrays, gas and cost, and here where the ith where the amount of gas at the ith station is gas I. So at every ith index, so the value of ith is the gas we can get from that in station, and the cost I is the amount of fuel that we burn to reach for the ith index. Okay, so we have two arrays, gas and cost. Gas I is the value of ith index that we can get the fuel of that particular station, and cost I is the uh, value that we burn to reach with a particular ith index. So this is the question. So now let's understand the example cases. So we have a both arrays like, so it contains 1 2 3 4 5 and cost 3 4 5 and 2. So at ith index we can get one amount of fuel, and the cost of getting that index, that is 3, that is more than that. So in a whole, in this situation, the problem, just think about, if the total gas, if the total gas is less than the cost, then okay, simply, so it's impossible to complete the circle, so we return -1. So in that case, in another case, if the total gas is greater than or equal to the cost, so yeah, this is the perfect scenario that where we can find the starting point. So we will use the greedy approach in the question. So yeah, this is the question. We move forward. First condition we'll check, okay, the total gas is greater than or equal to the cost. Okay, it's not, then return -1. If it, then we'll check the starting point. So for that, I'm going to write code. So just look at it. So I've written out the solution of this problem. So let's understand line by line. So here in total gas uh, is basically the differences between the ith index, like for the particular index how much gas we can get and how much cost we have earned to reach the index. So this is the difference, and the start is the starting point. So in the end we return that based on the conditions. So and the in total is equal to zero is totally something. This is the current, it's basically track the current fuel uh, in car. Okay, so this is the basic simple loop. And int gain, so get in gain here we are storing the differences. And at for each I we store the gain, it's a total gas. And yeah, same for tank. And if tank is less than equal to zero, so yeah, if tank is less than, it's negative, it's mean we have to move for the forward index. So we change the start is equal to I plus 1, and we can uh, just refill tank is equal to 0. And in the end return total gas if the this is the same condition I have discussed earlier. So if total gas is greater than equal to 0, so why is 0? Because we are storing the every gain, means every differences. So that's why it's greater than equal to 0, then we return the start point. And if it's not, it's minus 1. It's basically the problem, simple thing. Like if the total gas is greater than equal to the cost of uh, just reaching that index, is the sum of both the areas is greater than the total gas greater than equal to the cost of the sum of the cost array. So we have written minus 1. If it's not, so we will check the condition. So here is the condition. So yeah, it's a simple problem. I hope you will get the intuition. So yeah, just try to run it. So here total, I make a mistake. Okay, let's see the, it's done, it's submitted. Well, it's a very classic probability approach. So yeah.